Okay, hi everyone. Good morning. I am here to get started for the first time with a serious schedule. So I hope everything goes well and God gives me the strength to continue, of course. So let me know in the comments if my voice is uh, too low or if you cannot hear me well. But the plan is here to go with the MCAT schedule, like timeline itself. I'm talking about the day of the exam. So right now we will start to tackle physics, chemistry sections, and I will have my tools with me here. Yeah, so if we come here, we will find how we can create our own tests with. So we can see that we have these 5 main content areas for the physics section. We have then the biochemistry section that we will do with biology. You can see it has 3 content areas. And we have reactions, functional groups, and stereochemistry and lab techniques for organic chemistry. And for general chemistry, we have these 5 areas. So for the physics and chemistry section, we will put our focus on these 3. And for the biology section, we will put our focus on these 2. And for the psychology section, we only have this. Cool. So now let's get started with these 3. And then we, after the 95 minutes, the first 95 minutes, we will continue with the cars section. Right now I'm starting a bit late, so afterwards I have to catch up with the amount of time that I'm slacking for the physics and chemistry. But let's start a thing here. Can we? Yes. So we want this to be our first section. We can always organize things later, right? So we have, for physics, the main topics are mechanics working. Let's just copy this if we can. Jack Weston does not allow you to. This is a hack, so I don't want everyone to misuse this feature, but you can just take a screenshot and so we can also write down here mechanics, work, and energy, fluids, electrostatics, mechanism, and circuits, electrostatics, magnetics and circuits. Then we have light and sound. Then we have thermodynamics. Cool. So these are our main content areas. I've done some studying for the mechanics, I remember, work and energy, but we can now get rid of this. And then we have the general chem. So we have Gen Chem, which goes as we have this here. Can we make this smaller? Yes. So for Gen Chem we have atomic structure and chemical behavior, kinetics, equilibrium, and gases, bonding, and reactions, solutions, and acid, base, electrochemistry. Cool. Nice. Okay, this is also over, and then we have org chem. Honestly, I think org chem is my weak spot, so definitely I need to work more on it. And fortunately, there's only these three main content areas. So we have reactions, lab technologies, and functional groups and stereochemistry. Lab technologies. Cool, now let's get started with these. So it doesn't matter where we start, but I would honestly prefer to start with organic chemistry, my biggest fear. Then we can go with the rest. Yeah, let's start with chapter 1, which we have for nomenclature. So again, as we go through these, so we're talking about reactions here and then functional groups. So we know that the nomenclature with the isomers, with the bondings, this can be functional groups, analyzing organic reactions. It is in the reaction part. Then we have alcohols, that would be in still reactions, as you can see here. Then we have reactions of aldehydes and ketones, and then we have aldehydes and ketones again with these reactions. Then we have carboxylic acid reactions, and then we have amides, esters, and anhydrides and their reactions, nucleophilic acid substitution reactions. Then we have the amino acids, peptides, and proteins, phosphorus containing compounds, synthesis of alpha amino acids. These are functional groups, I would say. This would be part of the lab technique, and I remember going through this a bit recently, but not in depth as we are seeing it here. And last but not least, we have the chromatography, titration methods, and stuff like this, where we have also the appendix to count for it. And then we have the biology. Amazing. Let's now go start with the first section. Let's start with the content overview. So we have IUPAC naming conventions. You have 5 steps. In step 1, you find the parent chain. It is the longest carbon chain that contains the highest priority functional group. So based on your highest priority functional group, you find the parent chain and you start from there. So it's the longest carbon chain that has the highest priority functional group. Then step 2, you have to number the chain in such a way that the highest priority functional group receives the lowest possible number. So once you find the parent chain, which is which is where you start, which is the carbon chain that starts with the highest priority functional group. It's the longest carbon chain. Longest is important here. This is the key word. It's the longest carbon chain that has the highest priority functional group. And then the second step would be and you would number the chain in such a way that it starts with the highest priority functional group. So in such a way that the highest priority functional group receives the lowest possible number. So it means that you start from that. Then you name the substituents with a prefix. Multiples of the same type receive di, tri, tetra, etc. Penta, hexa, right? What's for 7? We have hepta, right? For 8, we have octa, like octagon, where the UFC takes place. We then have nana, probably, something like that, for 9, and deca for 10. But anyway, the third step is that the subsequent substituents, you name them with a prefix, and the multiples get a di, tetra, tri, and then you assign a number to each substituent depending on the carbon to which it is bonded. So then you assign a number to each substituent depending on the carbon to which it is bonded. So each substituent gets a number. So you number the substituents based on the carbon that they are connected to, attached to, they are bonded to. And then the last step is you alphabetize substituents and separate numbers from each other by commas and from words by hyphens. So you alphabetize substituents and separate numbers from each other. Oh my god. Okay. So this is our practice question. Identify the parent chain and name the compound according to the IUPAC. So since we have to have them, I think we need the structure for this, but these are based on numbers. So I think this is the whole thing about numbering. So do we start from the lowest number, or so number the chain in such a way that the highest priority functional group receives the lowest possible number. So our highest priority functional group is ethyl, and it must receive the lowest number, so it should be A. And is the double bond is. So specifies a pentane chain with the double bond starting from the first carbon. So double bond has priority over ethyl, and then ethyl over methyl. For all functional groups and bonds and anything else for IUPAC naming. So we have here from the lowest alkyls, so ethyl, methyl, whatever. Then we have halogens. We can ask, what are halogens? Give me examples. Then we have alkynes, which are the triple bonds, I believe. Do we have them here by any chance? So these are for alkanes. Yeah, alkynes are triple bonds. So we can see here how these straight chains are named. We have methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane, ondecane, dodecane, tridecane. Then for 20 we have, so for 14 would be tetradecane, and so forth, pentadecane, hexadecane, heptadecane, octadecane, octadecane, nonadecane, and we have icosane, and then triacontane. Yeah, so that should do the job for now. So alkynes are triple bonds, alkenes are double bonds. The naming for hydrocarbons and alcohols, alkanes are named according to the number of carbons present, followed by suffix "ane." Hydrocarbon with no double or triple bonds, alkane, CN, H2N plus 2. So we know it's like, for example, C2H4, because 2 times 2 2 times 1 is 2 plus 2 is 4, and so forth. We have C2H 2 times 2, and then for what's for 8, for example, C8 2 times 8 16 plus 2 18, so C8 H18. Here we have it, C7 H16, 14 12 10 8 6 4. So from the first one it just starts with 4. Cool. Then we have alcohols that contain an OH group. The suffix "ol" or prefix hydroxy alcohols have higher priority than double or triple bonds. So here we have, then after alkynes, alkenes, and even amines, which are the nitrogenous ones, we have the alcohols, and then we have ketones, then we have aldehydes. Ketones are double bonds with the oxygen. Aldehydes is a double bond with the oxygen and then the carbon being attached to a hydrogen. And then amides is double bond with the oxygen, but then the carbon being attached to a nitrogen. And then we have esters, which are, I believe, we'll ask about that. Anhydrides, those are also, I think, it has nitrogen. But then we have carboxylic acids, where we have them for amino acids. So the acidic part of the amino acids comes from carboxylic acid, which is the double bond and oxygen and an OH group attached to the side. And for the peptide bonds, that also happens for, give me the functional group examples for each of them. Given functional group examples with the elements for each of them in the order of priority. Again. Carboxylic acids, COOH, contains carbon, oxygen, hydrogen. Then anhydrides, C double bond O, and then an oxygen, right? And then that oxygen is also attached to a C double bond O. I now get the gist. We have then esters, which is an alkoxy group, C double bond O, and then attached to a carbon instead of a hydrogen, which would be a carboxylic acid. And so I believe if the carboxylic acid makes a reaction, has like, for example, not when you make peptide bond, but with other substances, it can have esters. It can become an ester. Yeah. Then if it's a prefix, we call it a carboxyl. If it's, I don't know if there's a prefix for anhydrides, but esters is alkoxy. For amides, they are an oxygen double bond and a nitrogen, or nitrogen with like two hydrogens, one hydrogen in a carbon chain, or two carbon chains. And then we have aldehydes, which are basically the double bond O and with an H. And then ketones, yes, and then alcohols, and then amines we have here, and double bond, triple bond, halogens, yes, it's fluorine, chlorine, bromide, bromine, iodine, and then we have methyl, ethyl, propyl. Ask me MCAT style discrete question on these. Which of the following function groups would take precedence in naming an organic compound? So carboxylic acid. alkane, alcohol, ketone, aldehyde. I would go with aldehyde. Alkane, carboxylic acid, amine, aldehyde. It would be first carboxylic acid, and then the aldehyde, and then the amine, and then the alkane. Yep. So let's write what we need to do here. The orders. Yeah, okay, cool. I think we can just continue now. And we have CAE, AAK, 4 A's, and then HA. So we can go cars, allow, and let's do something with N. Create a mnemonic with the first 3 letters of each functional group in order of priority, starting with carboxylic acid as cars. Cars and every kite always keeps almond heads happy. No. Make something more meaningful and funny. Always keeping Aladdin's happy home alive. Careful and teeter. Well, it's not all of it, is it? It was 4 A's. Keeping alcohols? What the fuck? Okay, cars. Give me some words that start with and cars. And answer. Anticipate. Engines. Emits alderman. Cars anticipate engines emits alderman. Keeping. Quadruple A. Halogenic. Alkaline batteries. That might actually do the job. We need a mnemonic document for real. This can be long, but we need it. So I have to create a mnemonic. So let's write down in big letters here what we are. Okay, cool. Then we have diols containing 2 hydroxyl groups, geminal and vicinal. So for geminal if it's on the same carbon, and vicinal if it's on adjacent carbons. sets as oh, so I mean we have why do dials have with OH on the same oh, Gemini means twins. Did Kendrick Lamar use Gemini in one of his songs? Okay, I'm going on tangents here. Completely. By their ambitious discipline and practical nature. Jeez. I've been slacking on all of these. Determination, reliability, and strong work ethic. Goal-oriented and methodical in their approach to life, often striving for success. Okay. Now we know Gemini means twins here in the chemical terms. And vicinal comes from vicinity, which is the adjacent carbons. Then we have aldehydes and ketones. We have an aldehyde here. We have a ketone here. Carbonyl group. Ketones both have a carbonyl group. Do we have it here for ketones? So this is called the carbonyl group on terminal carbon for aldehyde and non-terminal C. So terminal refers to the fact that it is the last carbon in in the compound, the molecule. Then we have primary alcohols, secondary alcohols, so and tertiary. So this is dependent on the carbon attached to the hydroxy group. This carbon is attached to two other carbons, which is a secondary alcohol. Now for amines, it's the same shit. So an NH group is like an OH group. So C has see, yeah, the N is attached to a single carbon, 2 carbons, and 3 carbons. Now, which one has a higher priority between these? What is the priority order for primary versus secondary versus tertiary alcohol? Primary alcohols attached to a carbon atom that is bonded to only one other carbon atom. The carbon attached to the hydroxy group in primary alcohols is connected to a single. So it's tertiary, secondary, primary. And then we have the carboxylic acid, the highest priority functional group because it contains 3 bonds to oxygen. So it has 3 bonds to oxygen. Yes. Okay, so the more bonds you have to oxygen, the higher is your priority. And oic acid is the suffix. Then we have esters, carboxylic acid derivative where OH is replaced with OR. And amide replace the OH group of a carboxylic acid with an amino group that may or may not be substituted. Substituents attached to it. What is an aryl group? Aromatic compound. Where do aromatic compounds or aryl groups rank in the order of functional group priorities? They're treated as a substituent or a part of a larger molecule. Good to know. So aromatics are part of a larger molecule, like as substituents. So we have like benzene, phenyl, toluene. So the ene must come from double bond, right? Phenyl is derived from benzene by removing one hydrogen atom. It consists of a 6-carbon ring with 5 of the carbon's atoms participating in conjugated ring of pi electrons. The remaining carbon atom forms a bond with another atom or group. The chemical structure is represented as C6H5 and toluene is C7H8. I believe we will come to this later. So for now, we are done with chapter 1. Let's go over the Anki here. We have this right here. Let's go to the organic chemistry here. We don't have much time, so we need to get over with this quickly. So this is a what group? This is a aldehyde group, formyl group. So for aldehyde, we have formyl. Sorry. This one would be ketone group for ketones, formaldehyde. Wait a second. Where do we have this? That was not a ketone. So let's, can we draw here? Okay, not like this. So H and then C double, I believe this is how they write it. H is formaldehyde. Okay, wait a second. This is attached to this, so formyl group. We don't have it here. formyl. Yeah, so for this is formaldehyde. This would be a carboxylic acid, so carboxyl formic acid. So we're talking about the names, the commercial names, right? Is formic acid the commercial name for something else? Which is like a methanoic acid. Methanoic acid. Yeah. It's found in insects, particularly ants. Formic acid has diverse applications, including its use as a preservative and antibacterial agent in livestock feed, a coagulant in the production of rubber, a component in leather tanning, and as a precursor in the production of various chemicals and pharmaceuticals. Man, chemistry is deep. Man, I'm not even gonna bother for this. Ketone. Like, this is ethanone, as far as I'm concerned, but an acetyl group. Yeah. Acetyl group. Because it's 2 carbons. So CH3 here, and then R, acetyl. And how many do we have? This is an aldehyde with ethanol, which is formal, acetaldehyde. So we have done. So we have the C double bond, and then H. Now here it's H if this is CH3. Acetaldehyde. This then is acetan form like acetoic acid, acetic acid. Yeah. And now here we have, what else? And then we have a ketone on 2 carbons, propanoic acid, but this is not, like, this is propanone, acetone. Wait, so if acetone, that's so CH3 here, CH3 here, acetone. Doesn't make sense. If acetone has 3 carbons and these have 2 carbons, and then these are called acetaldehyde, should be another carbon here. And then if it's like this is acetyl. Yeah, the acetaldehyde is the exception. What else do we have? This is pentanone, dipentanone, acetone. How is this acetone? What is the chemical structure of acetone? (2,4-dione), pentane, 2,4-dione. So it's pentane, 2,4-dione. Acetyl groups are CO and then CH3. So attached to the central carbon backbone. So this is the central carbon backbone. Then you have this being attached to the back central carbon here. Is the third carbon the central carbon in acetone? Yeah, it's the ketone groups, not that. But don't we have acetone here? And then we have phenyl acetone, acetophenone. Why is acetophenone not called phenylacetone? Let's do a Google search here. So this is acetylphenone. This is phenyl acetone. So we have the acetone, and then there's a phenyl attached to the first carbon. But acetylphenone is the double bond carbon, the CO structure attached to the phenyl, and then there is another. So it's a phenone, but the aceto refers to the fact that there is what is acetyl group? Wait a second, I'm getting confused here. So acetyl is the C double O and an R and a CH3. Why is acetyl called so? So acetic acid is the CH3 on one side, on the left, C double O, and then OH on the right side. When acetic acid loses a hydroxyl group from the carboxyl group, it forms the acetyl group. Okay. So, yeah, this is acetylphenone, not phenylacetone. Now this is a this is like a phenyl alkane benzyl group. So the R is the rest of the thing. So this doesn't directly attach to the R, but attaches to a carbon that attaches to the benzene ring. So it's a benzyl group. Where do we have the benzene stuff? Yeah, organic chemistry is my arch nemesis, to be honest. But I'm gonna crush it. So we have the reactions of phenols. We have these phenols here, but no mentioning of phenyl group. So here we could add our take. Phenyl. Is benzene ring, and then C, and then R. Yeah, I don't see any other things here. Cool. Where are we here? What this is what? This is ketone. We have the benzene. We have the ketone. So this must be benzaldehyde. So this is an aldehyde, the benzene ring, benzaldehyde. This is benzoic acid. Get rid of the enoic, it's benzoic acid. Don't be annoying. Benzoic acid. This will be I believe this is an ether, so anhydride, benzoin, jeez, benzoin, lioin. What is benzoin? Two hydroxy, 1,2-diphenyl ethanone. So ethanone, 1 and 2 diphenyl, 1,2-diphenyl, 2-hydroxy. It's a balsamic resin commonly used in perfumes, incense, and traditional medicine. Benzoin resin has a sweet, vanilla-like aroma and is often used as a fixative in fragrances. Interesting. It's also a mild reducing agent. We'll come across that later. But anyways, this is benzoin. This is a ethene, but phenylethyl. So phenene, styrene. Honestly, fuck you, since I said phenene, but whatever. And this is so like a thingy attached to this. Yeah, I know. Acryl. Wasn't acryl with oh, it was aryl that was aromatic, not acryl. We have this one as acrolein. This is acrylic acid. This is formic acid, carboxyl group. Wait a second. So this one, because it doesn't have any R's, so if it has the R, then you gotta be a group. It doesn't have a name. So this one is not a group. This is a carboxylic acid. So it's acrylic acid. And then this one is a carboxylic group. Carboxyl group. This is what ion? Carboxylate ion. Okay, because of the double bond and the H. So it's negative because it has one more electron to form the double bond. It got rid of the hydrogen and it's negative. Okay, let's go for a 10-minute break and I'll be back for the car section. Peace for now.